All right, we're going to continue on with the second part of this review exercise. And the first part had to do with algebra. The second part has to do with whether you can recognize if a parallelogram might be a rhombus, a rectangle, or a square, and you have to be able to explain. Now, while you are copying these review questions, you have to put down everything it's asking you to do. Show your work and explain. So for just a minute before I show you my answer, what might you think that would be? Now we know it's a parallelogram because they are telling us that in the instructions. It's a parallelogram. Is it a rhombus, a rectangle, or a square? When I look at it, I'm kind of tempted to think it's a rectangle, but then I'm like, nah, all four of those pieces should be the same if it's a rectangle. All those are bisecting each other, which is what a parallelogram does. But the thing that catches my attention is that the diagonals are perpendicular. And we learned a theorem yesterday that said in a parallelogram, if diagonals are perpendicular, then the shape or the parallelogram would be a rhombus. So let's talk about what we said. We said the diagonals bisect, but that's just because it's a parallelogram. But since the diagonals are perpendicular, that makes it a rhombus. All right, so let's look at this next sentence. Instead of giving us a shape, they're telling us some information. It says a parallelogram has two pairs of adjacent sides that are congruent. So I kind of drew myself a picture. And now, of course, it's not a great picture, but it's a parallelogram. So opposite sides have to be congruent, but it said adjacent sides were congruent. Adjacent means touching each other. So these would be marked the same, but these need to be marked the same because they're adjacent. And since it's parallelogram, opposite sides need to be congruent. So this shape would look like this. And I think all of us would understand that that would have to be a rhombus. Sorry, I keep turning everything here. Okay, the next one says I have a parallelogram and the diagonals are forming 8 congruent angles at the vertices. So when I draw my picture, here's my parallelogram. When I draw my diagonals in, I'm getting 4 angles that are congruent. And the only way that's going to happen, remember, opposite angles have to be the same. So this angle would have to be the same. And it looks like these would have to be the same also. And the only time this is going to happen is when you have a square. Because remember, these were 90s to start with, and they get cut into 45s together. Okay, so this next question is kind of confusing. When I read it, I had to reread it. It says your friend draws a parallelogram with diagonals the length of x and y. Which special type of parallelogram could your friend draw if x actually equals y? The special parallelograms would be a rectangle or a rhombus or a square. That's what they're looking for, one or more of those answers. And so we understand that in a parallelogram, if our diagonals are equal to each other, that has to be a rectangle. It might be a square because the rectangle might be a square. So I would say maybe a square. And then the next says, which type of special parallelogram could you draw if the diagonals aren't equal to each other? Now remember, this is a parallelogram and your diagonals aren't equaling each other, so that would have to be when you have a rhombus. Because if it's a special parallelogram, the diagonals aren't equal, the only option there would be to be a rhombus. Okay, it says, a classmate draws the figure at the right and says that it is a square because its diagonals are both perpendicular and congruent. What is your classmate's error? You know, and I looked at this at first and I was tempted to say, what? But then I looked back and I'm like, these aren't the diagonals. They are trying to trick me. These are not the diagonals. The diagonals would have been running from vertex to vertex, vertex to vertex. They're trying to trick me. So what would I have to say? I would have to say the lines drawn inside the figure are not diagonals. so they cannot be used to prove the figure is a square. The lines drawn inside the figure are not diagonals, so they cannot be used to prove the figure is a square. Now, a lot of you would be tempted to think these are right because you're seeing the 4 congruent markings in the perpendicular, but again, these lines are not where they should be, going from vertex to vertex like a diagonal should go. And then the last question says, students are planning a courtyard garden. They want the garden to be a square. How can the students use ropes to check the garden is a square? Justify your answers and name any theorems you used. Right? So this may surprise you, but we're going to actually use the ropes as the diagonals because we know a lot of things about the diagonals of a square. So the ropes are going to become our diagonals. They should be congruent because the diagonals of a rectangle are congruent. And remember, a square is a special kind of rectangle. So I'm going to make my ropes congruent and they're going to be diagonals. Then I'm going to join the ropes at their midpoints because diagonals of a parallelogram bisect each other. So in order to make sure that this shape is also a parallelogram, when I join my ropes, I have to join them at their midpoint. And then the ropes need to make 90-degree angles because the diagonals of a rhombus are 90 degrees. Remember, they are perpendicular. So that will make the shape a rhombus. My shape is a rectangle, a parallelogram, and a rhombus. So that means it's going to be a square. So where my ropes in, the ends of my ropes would be the vertex, or the vertices of the square. I would draw my square like this. These would be congruent. This would be 90, and I would draw my square. So if you have to, take time to, stop the video and write that down and go back. My ropes are going to be the diagonals. They have to be congruent because it's a rectangle. The ropes have to join at their midpoint because the diagonals have to bisect each other. The ropes should form 90-degree angles because they have to be perpendicular inside a rhombus. And if my shape is a parallelogram, a rectangle, and a rhombus, then it will be a square.